Hey guys, Jay here with Word of Advice TV. In this video, I would like to show you how to read a furnace wiring diagram like this one. Now I do have to point out that furnace wiring diagrams are not as straightforward as AC wiring diagrams. A lot of information on furnace wiring diagrams, it's assumed that you already know it, that you know the basic sequence of operations, that you know how a furnace works. There's a reason why there's more videos on YouTube on how to read an AC wiring diagram and barely any on how to read a furnace wiring diagram. So if you're somebody that does not know much about wiring diagrams, I think this video would be a bad place to start. If I were you, I would start with the AC wiring diagram that I did a while back. In that video, I go over a lot of the basics before I dive into the AC wiring diagrams. So you would learn a lot of stuff from there, and then maybe come back to this one. I personally enjoy wiring diagrams. I think they're actually kind of fun. It's almost like a puzzle to try to trace everything, where everything goes, and in which order everything gets energized. But of course, on a job site, it's only fun if you have the time. If you're in a rush, a complicated wiring diagram, that's usually not something fun. But anyway, let's jump right in. So here is a basic furnace wiring diagram. This is a schematic and this is a ladder style diagram. And we will be going over both of them. Before we dive into this, let's just go over some basics real quick. So these are the colors I'll be using. I'm actually going to be drawing all of this out to show you where the power goes first and all of that, so we can better trace the wires so you know how this thing actually functions. So green will be ground, brown's capacitor, 115 volt hot, 115 volt common, 24 volt hot, 24 volt common, and drawing time. If I'm ever going to use a pen, I'm probably going to be drawing something. And then we also have the furnace sequence of operation. This is not the full sequence of operation. I have a video where I go over in more detail about the furnace sequence of operation. So if you want to know more about that, look at that video. This is just a summary of it. So in the beginning, we need to know this because this is like background information that is not included in the wiring diagram. So in the beginning, the furnace is on standby, so it's doing absolutely nothing. When the thermostat calls for heat, the furnace does a quick safety check and then it begins. The igniter is energized after the inducer motor is running. I wrote this in pen, but really the inducer motor should be number 4, igniter should be number 5. But anyway, inducer motor comes on, igniter is energized, gas valve is energized, the flame is sensed, then the blower motor comes on until the thermostat is satisfied, then the inducer motor and the gas valve are de-energized, the blower motor comes off, and the furnace is once again on standby. That was just a really quick run through, and I'll explain a little bit more about this as we go along. So I don't know if you noticed, but this printout is huge. Here's a normal size of a wiring diagram. It's really small. It would be really hard to trace anything on here. So I went to Office Max and printed out a blueprint size piece of paper. So it's all nice and blown up so we can actually see what's going on, and I can fit all the different colors in here. So let's start with the schematic. And the very first thing you look for when you're looking at a diagram like this is where the main power source comes in. So in our case, it's going to be the 115 volt power supply right over here. This is where the power comes in. So, overcurrent protection device, that will be the breaker in a breaker panel in most houses. So this is the breaker right here. That is usually closed unless something is wrong. Power goes into here. We're going to use red. Power goes into here. And then it goes to the door switch. The door switch on a furnace is a normally closed switch. It's a safety switch. So if the door on the furnace is closed, like it should be, then the power proceeds down the line. And if we trace it, it goes into L2 on the control board. So whenever you see a box like this with a bunch of lines going to it, that usually signifies a control board or an ignition module, some kind of a board, or basically the brains of the operation. So this here is our control board, and this is where it gets its main power. Now, this is one of those times where the wiring diagram doesn't show you this, but the power, it goes straight from here and in to the primary side of the transformer. There's no breaks in between, but that's not shown on this diagram. So again, one of those things that they just assume you know. And from there, the power goes down this line, goes over here, and goes into this side of the transformer. And actually, let's make this line a little thicker so we can see it better. There we go. And before we continue, let's also touch on the neutral. So our common is going to be this guy right here, going into this wire nut. So here's the furnace common, the main common. That will go into the neutral strip on the control board. So all of these guys right here, they're all going to be neutrals. There's 2 hot terminals, and all of these will be neutral terminals. And also at the power supply, we do have a ground as well. So there's our ground in green. And once the power goes to the transformer, it energizes the primary coil and then travels back down this common line back into the control board. This is like the control center. Everything goes here. After the primary side of the control board is energized, so let's just draw a line right here. Let's say it's energized. The 115 volts is converted to 24 volts. And that goes into this connector right over here that is labeled 10. By the way, whenever you see circles with numbers on them, it's kind of just like an identifier. So if somebody asks you, hey, which terminal or which connector were you looking at, you can just say number 9, or I'm looking at number 11 right here, or I'm looking at number 21 right over here. So that's what those little numbers usually stand for. But different furnaces will have different wiring diagrams. It's almost like every single furnace you go to, the wiring diagram is different. So it's not really a cookie cutter approach, it's more of a case by case basis. So the transformer, 24 volts, goes into the board again. And then here's the common from the 24 volt side. That also goes into that plug. This is a Molex plug, a big one. It goes into there. And sometimes there's also a ground that comes out from the transformer. It's not always there, but sometimes. And there's other times where I see there is no common coming out from the 24 volt side. It just goes straight to the ground. So once again, different furnaces, different setups. You'll see various things, but the most common setup is that the 24 volt side will just have 2 wires coming out of it. One will be hot and one will be common. So after the board gets 24 volts, once again, this is not shown in the wiring diagram, but this power will go to R on the thermostat strip on the control board. And from there, it travels to your thermostat through the thermostat wire in the wall, goes to your thermostat and energizes the R terminal. The thermostat wiring is not shown, but in my AC wiring diagram, I do explain how the wiring inside the thermostat works. So if you want to know that part, you can check that video out. But basically R is powered up on the thermostat. So everything we have drawn so far, everything we have drawn thus far on our furnace sequence of operation, so far we are only at furnace on standby. So this is what the wiring diagram would look like when the furnace is on standby. So as long as the breaker is closed, the furnace power switch is closed, and the door switch is closed, which is normally the case, this is everywhere where the power will be going. So now let's start turning some stuff on. Let's say that on the thermostat, the fan switch, you switch that from auto to on, which means the fan will be running 24/7. That will basically mean that R will send power to G in the thermostat, and that power will go back down and energize the G terminal on the control board, the thermostat strip. And this will tell the furnace control board, once it senses that there's power at this G terminal, this will tell the furnace control board to turn on a fan speed. On different furnaces, it'll be a different fan speed. Sometimes it'll have a specific speed allocated for just that purpose if you switch the fan setting to on. Sometimes it'll be the cool speed, and sometimes it'll be a low speed that gets energized when you turn the fan on by itself without the furnace or the air conditioner. In our case, since we're not going to be talking about the cooling, I'll just use the cooling speed once G is energized. And that will be high voltage now. By the way, these thicker lines, they're the high voltage ones, and the thinner lines, they're the low voltage. So once the board senses that there's power at G, it sends power to the blower motor. So if we trace this wire, it goes to the indoor blower motor, which is right here. Power goes into there, and here's our common coming out from it. Once again, everything goes back to the control center, which is the control board. That goes into the neutral right over there. And then the blower also has a ground. Here's the ground. So that's what it would look like if you switch your fan setting on the thermostat from auto to on. This is how it would light up. So now let's go ahead and turn the heat on. Right here on the thermostat, we have W1 and W2. There's not a lot of thermostats out there that are wired for a two-stage furnace. Usually, if it is a two-stage furnace, the control board will be doing the staging. So what it would do is run the low stage for about 15 minutes, and then after that 15 minutes, the control board has an internal timer. It'll switch the stage to second stage to finish off the heating cycle. But since we have W1 and W2 here, let's just pretend that this is a two-stage furnace and the thermostat is the one that controls the staging. Let's say your thermostat is set to 72, but then the temperature in the house drops down to 70. In that case, the thermostat will send power to W1, which is low stage. That power will travel down this wire and energize the W1 terminal on the control board. And the next thing that happens is the furnace does a safety check. And here is what that would look like. So our safeties, they're right over here. We have the limit switch here. There's pressure switch 2, pressure switch 1, because it's a two-stage furnace, there's 2 pressure switches. We have another auxiliary limit. I'm guessing this temperature limit is probably going to be on the blower housing. So if the blower motor burns out and that compartment starts to get hot, this will open and interrupt the circuit. We have PS3. PS3 is a pressure switch in the combustion box, which is a normally closed switch. And then we have a flame rollout switch and another flame rollout switch. And by the way, I actually have videos on most of these components here. Like the limit switch, I have 10 reasons why a furnace overheats. So if you want to know more about the limit switch, you can watch that video. I have a couple of videos on pressure switches, how to troubleshoot them and how to check them. I have a video on the flame rollout switch, a video on how to replace the motor and what the fan speeds are, another video for the inducer motor, one for the hot surface igniter, how it works and how to check it, and then also a couple of flame sensor videos as well. So for more information about any of these components, I would suggest watching those videos. I'll try not to forget to list all the videos that I'm going to be referencing here in the description of this video. But anyway, back to tracing. So we have a call for heat and now the furnace is doing a self-check. The limit switch, the high limit switch right here, this is a normally closed switch. So the furnace sends power to it from the control board. Power goes into the limit switch, and power should go right through the limit switch and go back in to the control board, which is the connector labeled number 5. So if the furnace does not sense that there's power coming back to number 5, it will not proceed with the furnace sequence of operation. So if this switch is open, instead the control board will be blinking some kind of an error code. It doesn't have it on here, but here's our error code. If that switch is open, it'll be blinking some kind of an error code instead of working like normal. But our furnace is working good, so that switch is closed. And then the furnace will also send power to the pressure switch, the low stage pressure switch. And I think that was number 5. Let's see. Yep, this one right here. Sends power to the pressure switch. And the pressure switch is actually a normally open switch. So the power should stop here. If, while the furnace is doing a self-check, it senses that there's power on this wire, once again, it'll blink an error code and it will not proceed with the operation. It also sends power to the second pressure switch, but this one should only close when the second stage is energized. So this is a normally open switch until the furnace has a call for second stage heating. There's also power applied to the flame sensor. So there's just a little bit of power going to the flame sensor, like that. And if for some reason, let's say the flame sensor is shorted out to the burner box, if the rod is touching something metal, the furnace will sense that and it will not continue with normal operation. So once the furnace does this self-check and it makes sure that the switches that are supposed to be closed are closed and the ones that are supposed to be open are open, it proceeds with the sequence of operation. So the very next thing that happens after the self-check passed is the control board will send power to the inducer motor on the low stage. So IND-LO, inducer low stage, sends power to the inducer and powers it on. So we got power going in, and then the common coming out of it and going into the control board. Once the power vent motor is energized and running, that will make a draft and cause a pressure difference, which will close our pressure switch. So the pressure difference is only enough to close the first pressure switch. So this switch closes and we have power that goes through here. Now, if something is blocking, let's say the intake pipe or the exhaust, then the furnace will sense that this switch did not close and it will not proceed with normal operation and instead blink some kind of an error code. Oops, I almost forgot to draw my ground on the inducer motor. Alright, so the pressure switch closed like it should because this furnace is not having any problems. Once the furnace checked all that, the very next thing that happens is that the igniter, the hot surface igniter, gets energized. So if we trace this line back to the control board, right there it says HSI, hot surface igniter. The control board will then send 115 volts to our igniter. Like that. Our hot surface igniter is going to start to glow, nice and hot. If it's not burnt out or anything, and if it is burnt out, then once again, the furnace will fail, and you're probably going to see some kind of an error code blinking on the control board. A few seconds after the igniter gets energized, the furnace control board also sends power to the gas valve from number 9 in our plug right here. So it sends power over here, goes down this line, and we have another series of safety switches. So there's the auxiliary limit that's on the blower motor, pressure switch number 3, flame rollout, flame rollout. These are all normally closed switches. So unless there's something wrong with the furnace, these switches should be closed. And since our furnace is in great condition and there's nothing wrong, all these switches are closed. And we just breeze right past them and energize the low stage on our gas valve. So the power goes into the gas valve and the common comes out and goes on this line right here. These two arrows, that's just a symbol for a connector. So if I had to guess, this is probably like a male connector and a female connector, insulated, where they get connected right here. And this line goes back to the control board. So now everything is running, and the next thing that happens is that the flame sensor is supposed to prove flame through flame rectification. I'm not going to go into that in this video, but if you want to know more about how a flame sensor works, I would check out my other flame sensor troubleshooting video where I talk all about that. So if the flame sensor is sensing the flames like it should be, then the furnace will continue to run. But if the flame sensor is dirty, let's say, if it's really dirty and it's not sensing the flame because of that, the furnace will turn the burners off and start blinking an error code on the control board. But on our furnace, of course, everything is good, so the flame sensor does sense the flame like it should, and after about 30 seconds, on different furnaces the timing is different, but let's say in about 30 seconds, our low stage gets energized for the blower fan. So heat low will go down here and energize the blower fan, and the common will go back into the control board. And bam, we got heat. The furnace is running like it should. By the way, I noticed that I colored this yellow, but it's actually a 24 volt common, so that should have been blue. So if the furnace has been running for 15 minutes and it still has not gotten to 72 degrees, the thermostat will then energize W2. So it'll send power down this wire and go into W2 on the control board. And once the board senses that there's power at W2, it will energize the high stage on the inducer motor, which is this wire right over here. And then the common stays the same. Once the inducer motor is energized on the second stage, the pressure difference will increase, and that should close the second pressure switch if everything is working correctly. So once that switch closes, we got power going down this line, and once again, right back into the control board. Like that. And at the same time as the inducer motor is energized, at the same time we have the high stage on the gas valve also getting some power from the control board. Let's see, that will be this wire right here, number 3. So there's power that goes into the high stage of the gas valve as well. Like that. And then back down the same common. So power is applied to the inducer motor and the gas valve at the same time. Now if this pressure switch does not close in a couple of seconds, the furnace will shut off and the error code will start to blink some kind of a pressure switch error code. So there you go. Now we have everything running on here. Everything did get colored. So after the furnace heats until it heats up to 72 degrees, the thermostat will be satisfied. It will stop sending power to W1 and W2. And that will turn off the inducer motor and the gas valve. And after about 30 seconds or so, it'll also power off the blower motor and the furnace will return to its standby mode. And just so we have everything colored in, let's just color in the rest of this chart, which is not much. Let's say you turn your air conditioner on. All this would do is send power from R to Y, and that will go to your outdoor unit and power it on. And then of course, there's a ground right here as well. Oh no, and I also noticed that I didn't color in my heat medium speed. Totally forgot to mention that when the second stage is powered on for heating, W2, the inducer motor is set to second stage, the gas valve is set to high stage, second stage, and also I forgot to mention that the fan speed on the blower motor is switched from low to medium speed as well. Okay, so that's all colored in, and let's just color in this one as well and see if there's going to be any differences with this one compared to the schematic. So on this side we have the ladder diagram, which is a lot less complicated looking and messy than this side. So let's trace everything out here. So our main power source would come in from this side. It says L2 and L1. The reason I know it's this side is because it has DS over here, which is the door switch. So we know that the main power is coming into here. So it's coming in from here, it goes to these open contacts and it stops there. And it does the same thing for the rest of these as well. You'll notice that on the ladder diagram, it doesn't have any kind of indication of a control board, but IGM does stand for ignition module. So that tells you that there's a control board involved. And I don't know why, but there's no kind of brake or switch before the hot surface igniter. So if you were to read this literally, it would seem like the hot surface igniter is just energized at all times, which it's not. So I think they should have drawn something here to indicate that until it's powered on, it will not have power. So I'm not sure what happened there, but I don't know everything. Who knows? And then on this side, we have the common. Like that, like that, like that. And also the common coming from the transformer. So this whole side gets energized. The transformer also converts the 115 volts to 24 volts. And there is something new on this one. We have a fuse. So there was no indication that there's a 24 volt fuse on the schematic diagram, but on here we do see that there is a fuse. So if this fuse is tripped, there won't be any power going to the thermostat or to the R on the control board. But in our case, the fuse is good. And the limit switch is also in series with R. Only older furnaces did this. And sometimes an indication of this would be a customer would call me and tell me, hey, my furnace thermostat, it just goes blank once in a while. It goes blank, and then in a little bit, it turns back on. It runs for a while, it goes blank, and just keeps repeating that. And the reason that happens is if that thermostat does not have batteries or batteries for backup, then that means if the limit switch opens because the furnace overheats, let's say they forgot to replace the furnace filter, then power will be interrupted going from R, and that will cause the thermostat to go blank. So power goes through the limit switch and power's on R. And then we have our commons on this side. Let's just go ahead and draw those in right away. Even though common is only in effect after these components get energized. Boom, 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 bam, just like that. So this is what the furnace would look like when it's on standby, when nothing is running, but the power switch is on and the door switch is closed. These are the wires that would be energized. So let's say the temperature in the house drops down and we have a call for heat. The thermostat will send power to W1 and energize this path right over here and send power to the power vent relay. And by the way, on this control board drawing right here, they don't show any relays, but in real life there would be probably like 3 relays over here. Usually they look like little black boxes. This would be for, let's say, the fan, the inducer motor, and then the inducer motor for high stage. So there will be a couple of relays over here. So we have indoor blower relay, signified by this circle right here with a coil inside. There's the power vent relay over here, and there's another power vent relay right over here for the second stage. After the inducer motor is energized, the pressure switch will close, and power will go through all of these switches and energize the gas valve. And of course, before the gas valve, the hot surface igniter would have turned on first. Once the high stage gets energized, the thermostat would send power to W2. It would energize the power vent relay for the second stage. That would close the second pressure switch right here and energize the gas valve for high stage. And if we go by the ladder diagram, it looks like the power vent relay gets energized first. So the inducer motor gets put to high stage first before the gas valve. Because once the inducer motor ramps up and the pressure switch closes, only then will the gas valve turn on. And of course, if the fan is turned on the thermostat, that sends power to G and powers on the relay. Now, I explain how the relays work more in my AC wiring diagram video, but let me just go over it real quick. These relays are basically the ones that close these contacts right over here. So these are normally open contacts, but once this relay gets energized, for example, if the indoor blower motor relay gets energized, then that will close these contacts and cause power to go through here and energize the blower motor. There would be another relay for the first stage of heat, for the low stage, and another relay for the second stage. Once those get energized, power goes through and energizes the indoor blower motor. And of course, the same thing is applied to the power vent motor. Once the power vent relay is energized, it would close these contacts, high stage for high stage and low stage for low stage, and send power through to energize our inducer motor. Well guys, I hope you found this video helpful and you learned a little bit more about furnace wiring diagrams. If you have any questions or comments about anything you saw in this video, please let us know in the comments below. Thank you so much for watching this video. Don't forget to mash that like button on the way out, and we'll see you next time. And if you're still here and not in the comment section below, let me tell you a quick dad joke. So there was a guy milking a cow at a farm, and it was a big farm. There's other employees there. And as he's milking that cow, a bull starts to rush at him. The bull is getting closer and closer. The other employees are freaking out, but the guy that is milking the cow, he is just completely ignoring it. He just keeps milking the cow. The bull got extremely close to the point where it's just a couple of feet away from him, and yet the guy did not even flinch. Everybody around him is already screaming. But to their surprise, the bull slams on the brakes and stops just a few inches before the guy, turns around and walks away. Afterwards, the other employees came up to him and asked him, "Hey, how did you know that the bull would not hit you?" And he says, "Easy, I know that this cow is his mother-in-law."